you don't know what laser tag is, basically you have a vest and then someone else has a gun and you're playing 1v1 or team versus team. You have a receiver and then someone else has a blaster, what we're going to call it. Basically, you shoot out a laser from the blaster, it hits the receiver, register it as a hit. We have a few hits until you die, so you have some chances. But starting with the receiver, it's kind of modeled after the Iron Man emblem, sort of like a geometric shape. And we use Fusion to design everything in-house. We 3D printed everything, and then on top of the 3D printed part, we have acrylic, which helps diffuse the light, and then also a magenta film, which helps pass through only the laser without any ambient lighting issues. And so for the vest, we also have some adjustable straps so that anyone can wear it, and it doesn't have to be too much of an issue.
So for the blaster, we have a custom-made blaster. This is one of the earliest prototypes. We were thinking of making an attachment connection. We ended up landing on screws for the connections just because it was more convenient and reliable. We ran into an issue where after printing a set of prototypes, we weren't able to print guns in the makerspace, so we had to cut down the blaster into 6 pieces and glue it all together. And then we added this laser cut picture of to describe the different teams. We have Predator versus Alien, thus our teams. And finally, in addition to that, we custom made our adjustables with the resin SLA printer. We believe we're the only team that used that. And
action. Alright, so this is now the electrical part of the laser tag project. Initially, we started off with the basic premise of laser tag being a blaster and a receiver, and we thought of using infrared communication first because we had several advantages in terms of range of communication and also different types of receivers that we could use that were more widely available. Though we ran into the issue of just any type of receiver being able to pick up IR communication, IR radiation, and so we ended up choosing actual laser diodes and phototransistors for the actual electronic components of it. So now we'll talk about actually the circuit that's inside of the blaster. We simulated it and designed it both in LT-Spice to find actual specifications for the components, as well as designed a 3D model for the perf board in KeyCAD to get actual sizings and components correct. Inside is basically just a couple of voltage dividers and a switch to allow current to flow to the laser diode in this compartment. There's a capacitor in both of the blasters that actually stabilizes the voltage to resist the power draw and the change of voltage in the battery, allowing it to last much longer. There's also a buzzer for every time you press the laser. A buzzer will shoot a sound, so any shoot.
And now for the circuit for the receiver, we have here an LCD screen that updates and displays every time you are hit, so it keeps track of your lives and also your health. So once we have that displayed on the physical receiver, we also have here a node MCU port that connects to an external screen that the CS team is going to talk about, but that allows us to actually see the scores that are just constantly being updated on the internet, which is really helpful.
So switching over to the software side of things, I actually worked on the low-level software design. So here's the actual algorithm that's running on the board that I developed, which is, so we can split it into the boot sequence, which will set up to display any local variables, and then it will set up the Wi-Fi chip and connect to the Blink server, which is over here. Then we have the sensor code, which looks for a hit. If a hit is detected, then we register the hit, and then we check if there's 0 lives. If there's 0 lives, then we reset the game and display the game over screen. If it's false, then we go back and look for another hit. And in between those, we actually update the server and the LCD on board. So you can see exactly what's going on here and over here.
And from the user experience side of things, I was able to develop an application, which you can see right here, that allows the user to make a reservation and use the product, our laser tagging. It was a simple application using the MERN stack, which is a combination of a database called MongoDB, React, which is a framework, and some Express to create the server. Yeah, and this is how the code looks. There's multiple pages. That's how one looks.
Yeah.
Okay. So right now we're going to do a testing round, and we're doing it in ambient lighting in these non-ideal conditions to show that our filter actually works in these non-ideal conditions. Evelio and I are going to do some stationary training to hunt down the xenomorphs. So we're going to be standing apart here from this table width, apart from each other. And we're going to try to shoot each other using our blasters. So are you ready, Evelio?
Yeah.
All right, we're ready.
Sleepy Joe on the mic.
They know the clock stops for Joe and Barack. We about to be cooking. You get the pan, I get the crock pot.
Take a look inside your heart. Is there any room for me? I won't have to hold my breath till you get down on one knee, because you only want to hold me when I'm looking good enough.
Come on, man.
Did you ever feel me? Would you ever picture us? Every time I pull my hair, well, it's only out of fear that you'll find me ugly, and one day you'll